How colors are produced. Before we talk about color, we need to talk about light. Light is electromagnetic radiation that shows properties of both waves and particles. Light exists in tiny energy packets called photons. The primary source of light we get on the planet Earth is from the Sun. A photon from the surface of the Sun takes about 8 minutes and 20 seconds for it to reach the Earth, 500 seconds to travel about 150 million kilometers. Inside the Sun, however, it takes many thousands of years for a photon to get from the core to the surface. Light is made up of wavelengths of light, and each wavelength is a particular color. The color we see is a result of which wavelengths are reflected back to our eyes. Visible light. It is the small part within the electromagnetic spectrum that human eyes are sensitive to and can detect. Visible light waves consist of different wavelengths. The color of visible light depends on its wavelength. These wavelengths range from 700 nanometers at the red end of the spectrum to 400 nanometers at the violet end. White light. It is actually made of all of the colors of the rainbow because it contains all wavelengths, and it is described as polychromatic light. Light from a torch or the sun is a good example of this. Why do we see colors? Now that we know that certain electromagnetic wavelengths have a defined color, let us consider why we see colorful objects. Color vision results directly from the sensitivity of the respective receptors in the eye to the light wavelength. We can see the colors of different objects, for example crayons or flowers, because they reflect and absorb the rays of light that fall on them. These objects do not shine with their own light, but absorb specific electromagnetic wavelengths from the visible light range, reflecting the remaining ones. We see a certain color because part of the radiation reflected from the surface of the object reaches our eyes. How objects are colored. Objects appear different colors because they absorb some colors, wavelengths, and reflect it or transmit other colors. The colors we see are the wavelengths that are reflected or transmitted. For example, a red shirt looks red because the dye molecules in the fabric have absorbed the wavelengths of light from the violet or blue end of the spectrum. Red light is the only light that is reflected from the shirt. If only blue light is shown onto a red shirt, the shirt would appear black, because the blue would be absorbed and there would be no red light to be reflected. White objects appear white because they reflect all colors. Black objects absorb all colors so no light is reflected. To know the different types of color we need to know about color cycle. A color circle, based on red, yellow and blue, is traditional in the field of art. Sir Isaac Newton developed the first circular diagram of colors in 1666. Since then, scientists and artists have studied and designed numerous variations of this concept. Differences of opinion about the validity of one format over another continue to provoke debate. In reality, any color circle or color wheel which presents a logically arranged sequence of pure hues has merit. There are also definitions, or categories, of colors based on the color wheel. We begin with a three-part color wheel. Primary colors, red, yellow and blue. In traditional color theory, used in paint and pigments, primary colors are the three pigment colors that cannot be mixed or formed by any combination of other colors. All other colors are derived from these three hues. Secondary colors, green, orange and purple. These are the colors formed by mixing the primary colors. Tertiary colors, yellow-orange, red-orange, red-purple, blue-purple, blue-green, amp, yellow-green. These are the colors formed by mixing a primary and a secondary color. That's why the hue is a two-word name, such as blue-green, red-violet, and yellow-orange. RGB. Another way to describe colors is the RGB model. It is a way of expressing color space in a coordinate system, described by the RGB abbreviation, originating from English names of colors, R, red, G, green, B, blue. It is based on the impression of seeing by a human eye any color that is created by mixing three beams of light in these colors in specific proportions. Only this model can explain how the color impression in the human brain is created. Unfortunately, the model has a few drawbacks. Our ability to see colors is related to the interaction of light with a colored object. The color of an object is seen because the object reflects, absorbs, and transmits one or more of the colors that make up white light. The endless variety of colors is caused by the interrelationship of three elements: light, the source of color, the material and its response to color, and the eye.